problem number 30, you should all be paying attention. This will be a question on your test. No question about it. You're gonna have to
So what's the quiz going to be over tomorrow? What we like yesterday?
The quiz is going to be over whenever I decide it's over. And that's going to depend on how today goes. So hopefully we're all paying attention and being cooperative. Question number 30. Let's read it and see if we can think of a strategy that we used yesterday. How will this work? What do you think when you read question 30? What do you think of? Thank you. What strategy? Yeah? The tree thing, absolutely. What's going on in problem number 30, you guys? Meatloaf and peas. That's what's happening. Meatloaf and peas. Which one do I start with? Meatloaf. Because peas depend on meatloaf. Oh, excuse me, I got hiccups. So we're going to start with meatloaf. So we're either going to have meatloaf or we're not going to have meatloaf. What's the probability we'll have meatloaf? I apologize for my hiccups. Please read the question carefully. 20%. 1/5. 20%. Are these percentages? Yeah. So there's a 20% chance I'll have meatloaf and an 80% chance I won't. Now, where did he get the 20%?
It only happens 1 out of 5 days.
1 out of 5 days. 1 out of 5. Everybody see that? Now, I'm either going to have peas or I'm not going to have peas. If I have meatloaf, what's the probability I will have peas? 70%. So then the probability I won't have peas is 30%. Now what if I don't have meatloaf? No meatloaf. What's the probability of peas? 30? Now for those of you that are clueless, these numbers are in the problem. We're just reading the problem. You got to have a book, got to have it open to the right page, and you got to be reading it. That's where these numbers are coming from. Now, what do I do? There are 4 branches to my tree. What do I do to these 2 numbers right here? I multiply them. So that's going to be 0.14. Now, I multiply these because this branch represents meatloaf and peas. And means multiply. This would be 0.06. That is meatloaf and no peas. This would be 0.24. That's no meatloaf and peas. And this would be 0.56, which is no meatloaf and no peas. What did I tell you yesterday about this row of numbers? They have to add up to 100%, or 1 in this case. They have to add up to 100%. That's your check. If they don't add up, then you've messed something up. Now, what's the question? This is number 30. Oh, there's 3 questions. Number 1, what's the probability the cafeteria serves meatloaf? You already told me, 20%. What's the probability we serve meatloaf and peas? Meatloaf and peas, that probability is 14%. What's the probability we serve peas? Well, peas are here and here. So we could have peas with meatloaf, or we could have peas without meatloaf. So if it's this or this, what am I gonna do with these two numbers? Add them. So the answer would be 38%. Anybody else have a question about one of those homework problems?
Nah, bro.
Okay, would you find then in your packet that I gave you, not your note sheets, but the other thing, we got Precal practice test 1. Woo! Let's get it out. Huh? Yep. Right now, I don't know, I'm still considering because of the play, there's a lot of kids involved in the play, so I'm trying to figure this out.
Yeah,
Right now, we're planning for Friday.
Yeah, the music.
Yes, next page. Yeah, on the front page of the packet says in-class review.
It's forward. You know, I was a childhood actor, right?
He was.
The front page says in-class review. We are looking at page 2, which is the practice test.
Oh, 9193.
Yep. Okay, there's a lot going on here. Here we go. The front page of the packet says in-class review. We are on the second page. We're looking at the practice test. We're looking at the practice test. So Ethan, turn the page. We're looking at the practice test. There we go.
Attaboy, Jabron.
Number 1. In how many ways can 7 books be arranged on a shelf? 7 factorial. If you said 7 factorial, you are awesome. Type it in on your calculator. Tell me what you get. 5,040. So the answer is 7 factorial, 5,040. Number 2, how many outfits are possible if you have 4 pairs of pants and 6 shirts? 24 outfits. How did we get 24? We multiplied our options. We multiplied 4 times 6. Good. In how many ways can you answer 8 true-false questions?
What, isn't that when you take 8 times 7 times 7?
Isn't it 256?
Yes. How did you get that, Ethan?
Because you do 2 to the 8th power because you're answering it twice, so there's true and false. And
2 to the 8th power. Very good, Ethan. When you sit down to answer question number 1, how many choices do you have?
2.
2. How many choices do you have for this question? 2. Don't you have 2 options for every question? So what do we end up doing then? Multiplying 2 times 2 times 2, 8 times? Which he said 2 to the 8th power. Now what if these had been multiple choice questions with 3 options, A, B, C? Then it'd be 3 to the 8th, right? Because you have 3 choices for every blank. How many ways can I get a pencil, a marker, and an eraser to 3 students in, my typing is not very good, in a class of 12?
220.
How'd you do that?
12C3.
Should it be 12C3 or 12P3? Why P? It is a P problem, and why is it a P problem?
Because order matters.
Because order matters, because the prizes I'm giving away are different. If we have different jobs, different prizes, different rules, different whatever, it's going to be a P problem. Everybody got it? So it's 12P3, type that in on your calculator, what's 12P3?
1320.
Is he right?
Yeah.
Damn straight.
How many 8-letter words can be formed from the letters of prettier?
Oh, we got some repeats.
We have some repeats, but before we get to the repeats, what do we start with? 8 factorial. Because there are 8 letters. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 letters. So I start with 8 factorial. Now what do I divide by?
2 factorial.
2 factorial for the R's. 2 factorial for the
E's.
T's and
We got
E's.
2 T's.
Is that it? Now, notice you have more than one thing in your denominator. Please put parentheses around that. So it's 8 factorial divided by 2 factorial, 2 factorial, 2 factorial. Should be 5040,
What?
5040. Would somebody confirm that? Thank you.
Yeah.
Now, those of you not practicing with a calculator are going to be in trouble, because on test day, you've got to know how to use the calculator, and you're going to have to be efficient, because you have a lot of questions to answer. How many ways can 10 people be seated around a campfire? 9 factorial. Remember, kids, when we do it in a circle, it's 1 less. So if we said, let's put 10 people on the bench, that would be 10 factorial. But if we do 10 people in a circle, it's 9 factorial. And what is 9 factorial?
362,808.
362,880.
Yeah, we need a calculator.
Number 7. How many committees consisting of 3 boys and 5 girls can be formed from a class of 10 boys and 8 girls? We're on number 7. What are your thoughts? My Brownlow, you got a thought on problem 7?
I'll just listen.
Okay, now Maya, stop. How many boys are there in the group total? How many boys do I have total?
10,
And how many of them do I need to pick?
3.
Okay, so I need to decide, is this gonna be 10P3 or 10C3? So read your problem. Does it seem like order matters? No. So that's gonna be 10C3. So 10C3 takes care of the boys. But don't I also need to pick girls? So I'm picking boys and girls. So I'm gonna do a multiplication. And now I'm gonna pick my girls, Maya. 8C5. That's it. Isn't that easy, Maya? Do not sweat it. It's easy. Let's type it in, make sure we have the right answer.
6,700.
Would you, if you're gonna speak, would you at least speak in a language we can understand?
6,720. I thought that was perfect, didn't it?
He's right. 6,720. probability of being dealt a 5-card hand that is composed of all diamonds. Now, kids, remember, probability will be a fraction. So this problem has to be a fraction. Okay, you're backwards. It'd be 13C5 over 52C5. Remember, the big number has to come first. Now, he is exactly right. We're going to type this in and get our decimal. But can somebody explain to me, not Patrick, he did it perfectly. Can somebody else explain to me his thought process? Jabron.
So there's 13 diamonds in a deck of 52 cards, so that's a 13, and you only need 5-card hand.
Yep, that's it. There are 13 diamonds. We want all diamonds. There's 13 diamonds in the deck. We're going to choose 5 of them. Why is the denominator 52C5? Because that's total cards in the deck. Your denominator is always the total in a probability problem. So, decimally speaking, what does that work out to be?
0.000495.
This is such a pain in the butt. Yeah, so it came out in scientific notation. This is what my calculator says, so I gotta pay close attention to this. This means 4.95 times 10 to the negative 4th. Yeah.
Can we leave it like that?
Yep. What is the probability of being dealt a 5-card hand that has exactly 3 aces?
Miss Ware, I have a question.
Yes.
Come the test, see, the only game I've played maybe is Goldfish, so I don't really know all the stuff that's in the deck. Are you gonna like give us, or is that not a thing? I gotta learn it.
It's not that hard.
I don't. I got you. Before the question. Thank
You need to know, you need to be familiar with the deck of cards, yeah.
I can explain it to you.
Now, what is the probability of being dealt a 5-card hand that has exactly 3 aces? What's the denominator of this going to be? It's a probability, so it's going to be a fraction. 52C5 is your denominator. Why? Because the denominator is the total, always. It's a 5-card hand out of 52. Now, the numerator says exactly 3 aces.
So
Okay, now wait a minute. How many aces are there in the deck?
4.
4. And you are going to pick 3 of them.
So it'll be 4C.
So
4C3. But you're not done.
it would be, wouldn't it be minus or plus, multiply, times, it would be what's left over. So that's
48C2. Let me explain this now for those of you who might be confused. Your deck consists of 4 aces and 48 not aces. Let's welcome Mr. Mauger.
Good morning.
Oh, there's the book I wanted.
Oh, look, but it's from the school city of Vienna.
I'm sure it's mine now. Thank
That must have
you.
been when I worked at Clark High School. I must have taught geometry that year.
Thank you, Mr. Mauger. Lots of stats.
Does that dog need a friend?
God, how long has that been there?
This is how you never that today.
A real dog?
I have another dog for it.
Oh, sure.
Okay, cool joke.
I'm allergic to dogs.
How long has that dog been there?
Dog's not real.
I know it's not real. I think it's just been working.
Well, one of my, I've got 3 daughters, and one of the girls had a boyfriend that had a dog that looked like that. Her name was Dakota. But now that he's no longer in the picture, So he had given my daughter this thing, but of course now that he's out in pictures, so she doesn't want the thing anymore. So. Okay. I may give him away at some point if someone wants to.
I'll take it.
Now, we have a 5-card hand that has 3 aces and 2 other cards. Kids always forget those 2 other cards. They're not mentioned in the problem, only the aces are mentioned. It's a 5-card hand. If 3 of them are aces, there have to be 2 more that aren't aces. So there are 4 aces in the deck, and you are going to pick 3 of them. There are 48 non-aces in the deck, and you need to pick 2 of them. These are multiplied because it's 3 aces and 2 other cards.
Okay.
Then we divide by 52C5 because that's how many total cards there are in the deck, and that's how many total cards I'm picking. 52 cards total, picking 5 of them. If it rains tomorrow, the probability that I'll play tennis is 15%. If it doesn't rain, the probability that I will play tennis is 90%. The probability of rain tomorrow is 45%. Find the probability I'll play tennis. Okay, when you see this problem, when you read this problem, what do you think?
Rain or no rain?
You think about tree diagram, I hope?
Oh, yeah, tree diagram.
And at the top, we're going to start with rain or no rain. Now, why do we start with rain or no rain?
Because tennis is dependent.
Exactly. Tennis depends on that. Tennis has to be the second level because it depends on the first level. So if it rains, I'll play tennis or not.
Or no.
And if it doesn't rain, I'll play tennis or not. Now, what's the probability of rain? 45%. So then the probability of no rain is 55%. Now, if it rains, so here we are, if it rains, what is the probability I'll play tennis?
0.15.
0.15. So the probability I won't play tennis is
0.85.
0.85. Katie, why are you not writing this down?
I already did.
You already did it?
Yeah. I know, I got 2.
Oh,
Awesome.
snap, Katie.
She said, what you talking about?
Now, if it doesn't rain, what's the probability I'll play tennis?
90%.
So I won't 10%. Now, I multiply each branch together, so here we go. Rain and tennis would be 0.0675. Rain and no tennis would be 0.3825. No rain and tennis is 0.495. And no rain and no tennis is 0.055. Now, what's the question? Find the probability I'll play tennis. Now, I can play tennis here and here. In other words, I can play tennis if it doesn't, or if it does rain, or if it doesn't rain. So what am I going to do with these 2 numbers right here?
Multiply.
No!
Add.
I'm going to add them.
Who said
Somebody tell him why I'm going to add them. Because it's rain or no rain. It's an or situation. I'm going to play tennis if it rains or if it doesn't rain. 0.5625. there are 50 seniors in the chapel. All of them enjoy singing and or praying. If 25 indicate they enjoy singing and 32 indicate they enjoy praying, how many enjoy only praying? I heard somebody say it. It's a Venn diagram problem. Doesn't it just feel like a Venn diagram problem? You have people doing stuff overlapping. So our Venn diagram will have 50 people in it. And everybody is either singing or praying. All right, now, I want you to think about this for a minute. Pretend the 50 people are in this room. Okay? There are 50 people in the room. I say, raise your hand if you enjoy singing. And 25 hands went up. Say, okay, put your hand down. Raise your hand if you enjoy praying. And 32 hands went up. Now there's a problem.
It's more than 50.
It's more than 50. What does that mean?
Yeah, people like both.
People like both. How many more than 50 do I have here? 7. So that means 7 hands had to go up twice. 7 people got counted twice. So right here is a 7. Now how did we figure that out again? Because only got 50 people. So it's the extra. Now, the whole singing ball is 25. But there's 7 of them already counted, so this would have to be 18. The whole praying ball is 32, but there's 7 of them already counted, so this would have to be 25. Question says, how many enjoy only praying? Only praying? 25. 18 is
So on the test, if we can figure it out without, or do we should probably draw the diagram?
There's no rule that says you have to draw that diagram. Taylor?
So there's no like side, the little bottom number for problems like this, only the decimal ones?
No. There could be a number here, but look, what did these add up to, Taylor? So everybody's in there. It would be if they only added up to 48, then there would be 2 extra people out here. Okay, number 12. Expand. Okay, do you remember what this means? This is switching gears a little bit. This is the triangle, very good. So let's build our triangle. Not talking about tree diagram now, talking about Pascal's triangle. You remember how to build it? Oh my goodness.
Keto, K-E-T-O-N-E.
Okay.
I'm gonna name my child.
What happens if I forget his name?
You can email me, I'll tell you.
I'm gonna miss him so much.
Not as much as you'll miss me, right? See you this summer.
All right, remember the triangle, we start with a 1 and a 1. Then I put a 1 on each end and a 2 right here. And where does that 2 come from? 1 plus 1. Put a 1 on each end. 3, 3. A 1 on each end.
It's not hard.
4, 6, 4. If you don't know how to build that triangle, you need to spend some time with your next door neighbor because we went through that 2 days in a row.
I wasn't here. From school.
Yeah, exactly.
Well,
Now,
never just ask for help.
if
She
we
don't know
are
either, so-
expanding, then we're going to write down that whole row. Now, next we're going to do problem 13. And problem 13 doesn't require us to do the whole row. But number 12 means the whole row. Now, do you remember that next to each of these numbers, I write something? Not X and Y. What do I write in this problem?
The number.
X and negative 2y. X and negative 2y. I'm on problem number 12. Where is this coming from?
Wait. How does this even go with this?
Where is this coming from? Look at problem number 12. It's coming from the problem, you guys. Look. It's the two pieces of the binomial that you're expanding.
So,
Now we need to put in the exponents. This is to the fourth power. So the very first x exponent would be 4. And then what happens as we go down the line?
Does it matter?
3, 2, 1, 0. Now what happens to the y's? Backwards. 4, 3, 2, 1, 0. Now let's put plus signs here to separate these terms so we don't get them confused with each other. And now we're going to simplify. This is easy. Anything to the 0 power is 1. So this is just x to the 4th. Bryce?
Does it matter which way you go? Like if I put 0 for the x. 0.
It does matter.
It does?
It does. If they were just if this problem were just plain x plus y, then it wouldn't matter. But since we have a minus and a 2 in there, it's going to matter. Okay? The power on the first letter, whatever the first thing is, that should always be this one.
Okay.
All right, how about the next term? Did you get this one yet? Minus 8x cubed y. How did I get 8? 4 times negative 2. These are all getting multiplied together, kids. Be careful. What's that one going to be?
Yeah, negative 12. Oh,
Maybe
negative
24.
12 x, y.
Positive 24 x squared y squared.
Okay, you want to.
It's positive 24 because what happens when you square negative 2y? You get 4. So 4 times 6. How about the next one then?
Negative 32.
Very good. Negative 32 xy cubed. Why is it negative 32? Because this makes negative 8. And then how about the last one? 16 y to the 4th. Positive. And that's the answer. All that is the answer.
Okay, the second time you put the exponents in, like on the way back, where did you get those from?
They're exactly the same, just going the other direction.
Oh.
So here I have 4, 3, 2, 1 on this end, and I do the same thing down there. All right, next question says, okay, instead of finding all the terms, we just want to find the third one.
I feel like you don't be listening to me. That's why I know.
But it's to the 7th power. Now, who remembers a shortcut to get the 7th row of numbers. I could keep writing this out. And if on your test that's what you want to do, that's fine. But there is a shortcut to get the 7th row. Does anybody remember what it is?
The answer is no.
Oh.
You guys,
It would be 17.
1, 7.
they are the combination numbers. So the first number in the row is 7C7. That's talking about the 7th row now. The 7th row. The first number is 7C7. The second number is 7C6. And the third number, which is the one I want, is 7C5.
So that was our answer.
Well, that'd be the coefficient, that'd be like the 6, that'd be the number part. So 7C5 is your number, and then we have a 2x and a y. Because those are the two parts of this problem. Now, 7C5 is 21. Now I need to put my powers on my parentheses. If I were to write out the whole row, what would be the power on the 2x term in the very first term here?
0.
No, 7. Remember, it starts with 7 on the first letter and counts down.
X is 7.
So the first exponent would be 7. The second exponent would be 6. And the exponent on the third term would be 5. So if this is a 5, this one would be a 2 because they have to add up to 7.
Wait, how'd you know the X was the 5 again?
Because this is where it starts with 7. When you put on your exponents and you start counting down, that starts with 7.
Then you go 2 down.
Then you go down. Now, I'm not finished. What is 2x to the 5th power?
32.
32x to the 5th. So now I need to multiply 21
672.
times 32. So 672 x to the 5th y squared is your answer. Now, we're out of time. So tonight you will start with number 14 and you will do 14, 15, and 16. The answers are provided, so please check. And tomorrow we will talk about the ones that you don't know how to
Do you have a
do.
4th period class?
Can I take this test? Monday, 8th or 9th?
Why would you?